right, hello. This video is talking about the introduction to trigonometry. So we've done some work with right triangles before, but we're going to use some specific language and focus in on some specific things today. So I have my hippopotamus on my hypotenuse here to remind us of some things that we want to remember. Or if you weren't in geometry before and this is new information, we're going to go over this quickly. So the first thing that we want to know is that we are working with right triangles, and right triangles have one right angle, and a right angle measures to 90 degrees, and two acute angles, and acute angles are less than 90 degrees. Okay, so this is an example of a right triangle because it's got that little marker in here that says that it is a right angle, and I have two acute angles. I'm going to draw a symbol at letter X down here. That's that circle with the line through it, and that is called theta, which is where we are. It tells us where we are standing at and where we are basing our names off of. The opposite side of a right triangle is always across from theta. Okay, so if I go to theta and I go to a side that's across the triangle from it, I get to the opposite. The adjacent side is always between theta and 90 degrees. So if my theta is here and my 90 degrees is here, this side on the bottom is my adjacent side. And lastly, my hypotenuse is across from your 90 degree angle. So 90 degrees across the circle gives you your hippopotamus, or your hypotenuse with a hippo on it. So those are our reminders we want to keep in mind and some language we're going to use as we go through this. Now, the area of trigonometry is an area of geometry that studies right triangles. Okay, so we're only going to focus on right triangles, and specifically looking at their side lengths and their angle measures. Okay, so we are specific to right angles, or right triangles, and looking at how are their side lengths and how are their angle measures connected. There are three functions that we use, and functions is like an action on a number. So it's like square root or an equation, something that's going to change our value. And they have names. They're called sine, and we pronounce it sine, like a stop sign, and we abbreviate it SIN. Cosine, which is COS, and tangent, which is TAN. So those are the three functions that we are going to use that create a relationship between our side lengths and our angle measures. So trig functions are operations on acute angles that represent a ratio. Now, a ratio is like a fraction or a relationship. Okay, so what it's doing is it's saying if I take the sine of an angle or do this thing to an angle, it's going to give me a fraction that shows the relationship between side lengths. Okay, so everything is about relating an angle to, in my fraction, a side and a side. So my first function is called my sine function, and we say that the sine of something is equal to the opposite side of a triangle over the hypotenuse of the triangle. Meaning that if I have my angle theta here, if I take the sine of this angle theta, so the function of that angle, it is going to give me a decimal that is equal to the same thing I would get if I took the opposite over the hypotenuse. Okay. The next function that I have is cosine. Cosine is similar to sine. This time we have our adjacent side on top divided by our hypotenuse. So if I have theta in the same spot, if this time I take the cosine of theta, I'm going to get whatever the adjacent value divided by the hypotenuse is. Okay, so they're different functions on the same angle that relate different sides. Now, sometimes I don't have a hypotenuse or I don't want to use my hypotenuse. So tangent doesn't use hypotenuse, and it has the opposite side over the adjacent side. So if my theta is in the same spot, I use the two sides that do not involve theta or hypotenuse. I have an example using this. So the first step I'm going to do is draw my theta at angle N. The reason I draw my theta at angle N is because that is the angle that I'm taking the function of. When I look at all of these, I'm taking the sine of N, the cosine of N, the tangent of N, meaning of that angle N. So I draw my theta there to keep that in mind. Now I'm going to label my sides. Well, across the triangle is going to be my opposite. That's at 5. Between my theta and my right angle is 12, so that's my adjacent. And across the triangle from the right angle is my hypotenuse. So now I have side lengths or number values to put in for each of those sides. I know that the sine, and I can look at my notes, the sine is opposite over hypotenuse. So I'm going to take my opposite value of 5 and put it over my hypotenuse value of 13. Next, I'm going to do the same thing for cosine, but cosine is adjacent over hypotenuse. So the cosine of N is using the adjacent when we're at N, which is 12, over my hypotenuse, which is 13. Lastly, tangent is opposite over adjacent, which is equal to my opposite value of 5, my adjacent value of 12. And I can leave it here. These are my answers, those fractions, okay? Because ultimately we're working with decimals and fractions to relate sides and angles. Okay, so it's okay to leave it as the fraction. Now at the bottom of your note page on the front side, you might have seen something that looks like this. SOHCAHTOA. We say SOHCAHTOA. And what SOHCAHTOA means is that the S stands for the sine, the C stands for the cosine, and the T stands for tangent. Now if I think about, okay, what do I know about sine? Well, I know it relates the opposite over the hypotenuse. So this is opposite hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So this is a good little phrase that you can use to help you keep in line what different functions each, or which sides each function uses. So sine uses opposite hypotenuse, cosine uses adjacent hypotenuse, TOA, tan uses opposite adjacent. Lastly, I'm going to do the same thing I did before. This example does not have number values, it has letter values, but I can do the same work. So I'm going to look at, where do I put my theta? Well, the angle inside the parentheses that I'm taking the sine, cosine, and tangent of is L. So I'm going to put my theta at angle L, and then I start labeling across the triangle, opposite, between theta and a right angle, across the triangle from the 90 degrees is my hypotenuse. So I have H, W, and D as my values. Sine, I know, is opposite over hypotenuse. I can use SOHCAHTOA to help me remember. Opposite hypotenuse. My opposite value is H. My hypotenuse value is W. Cosine is adjacent over hypotenuse, which is equal to D over W. And then tangent is opposite over adjacent. So I get H over D. And so those fractions relate the sides to get the angle measure of our triangle.